The Value King is here. Well, 3 of them. I've actually had them for a few days. I've had this one tested out. This is the AMD 9060 XT here in Canada. This is the best value GPU money can buy by far, at least at MSRP. I'm not sure, the prices are going up and down. I got all of these at MSRP. If you're looking for something that is going to get you by with 4K Lite in modern AAA titles or 4K Max in older titles, or 1440p probably maxed nowadays, this is the GPU to go for. Get them like that. Look at that. Look at that tiny little guy. So cute. So cute. I like it. So yeah, we have all the 3 same rough GPUs. I mean, there's like overclocking and the clocks are slightly different, but I mean, they're basically the same GPU and you can just tune them to be the same, more or less. I'm going to do this stuff at stock, I think probably is how I'm going to do this. And that leads us to the differences between them, which is essentially just cooling solution. That's really it, right? Like, you can get slightly different with like OC versus non-OC models, the clock models, whatever, you know, what they're based at, you know, those are slight differences, but you can just change those things, right? Like, that's just out of the box overclocking and stuff. But the differences are clearly going to be the cooling solutions. So let's come in here and go like that. We'll have a look at them and we will tear. I'm actually going to tear them down. I'm not just going to like look at them. That's just not my thing. So you can see there the size difference. The XFX is definitely the largest. The PowerColor is definitely the smallest, and the Sapphire is right in the middle. So there's a big difference in length there. I mean, I guess I can bring out measuring tape. You can just look it up, but I sometimes do find it a little hard to actually find this information on a kind of spreadsheet. So XFX, it's basically exactly 2 inches, just ever so slightly, 5.2 centimeters, or just over 2 inches. A little under 2, we're looking at 4.7 millimeters approximately. 4 centimeters, just under 4 centimeters there. Very, very close. And 1.5 inches. Jeez, 1.5 inches. So that's good. So there's a pretty big spread on the actual thickness too, not just the length. Length is going to be considerably different here, obviously. XFX, we're looking at a little over 10.5 or 27 centimeters. Sapphire, we're looking at 9.5 or 24 centimeters. The little baby Reaper, just under, actually it's a little even less than that. It's just, yeah, it's 8.5, 8 2/3, I'd say, inches, or around just shy of 20 centimeters. That's so small. I mean, they're all small, to be honest. This is like kind of like a traditional 2-fan. This is like more of like a traditional smaller 2-fan kind of, you know, that's usually the smallest you get if you get like a 4070, or if you get something in that kind of lineup, like the 70 tier, and you get a 2-fan, this is usually what you get. This is very small. This would be similar to something like a normal, like a 4060 is probably the closest I'd see to this, or 3060. So this is 2 slots. It's almost 3, probably 2.5, right? Sapphire is 2 and just a tiny bit extra. Reaper is 2, like actually 2. Fan diameter is actually quite a bit different. So the XFX, we're looking at just shy of 4 inches or 98 millimeters, something like that. A little bit smaller here. 9, is that actually true? Yeah, it is. 9 centimeters, just shy of 9 centimeters. And here, this is almost the same. Let's actually hook it on there. Looking at 8, 81, 82, 80, almost 83 millimeters. No, it is slightly bigger. Yeah, that's looking pretty good though. Now, you know, the cooling here, we do have a full length radiator. PCBs, obviously not. There's a lot of extra room here. So, you know, this is the PCB. Let's line these up here so we can actually have a look at the PCBs here. I'm going to do them in flip, but all right, like, so that's where the PCB ends. That's where it starts. The PCBs are the same length, right? So we have PCB to PCB. Right, the PCBs are the same length here, or within like 0.5 millimeter from me eyeing it. So the difference in PCB, right? So this here, you know, you get the PCB length being the same, basically, with, you know, how much extra cooling over here, you know, a little, like basically an inch of extra like fin there with a little bit extra overhang for the fans. This is the same PCB length, right? The difference here is you get a lot more just fin. Overall fin over here, right? You get over here 3.5 inches or 85 millimeters extra. So quite a bit more just general fin there with fans going through. So there's just more, and you can see the heat pipes running through. Over here, we're looking at 70 centimeters, 70 millimeters, and 2 3/4 inch over there for the extra cooling there. And again, PCB got the same spot, but we're still getting heat pipes running through with extra fins here. It's the same, it's just the length. So generally speaking, I mean, we're getting, in summary, in terms of the cooling, size and dimensions, I mean, they are quite a bit different. There's also differences this way too, right? So right there, we're looking at 9.5 centimeters exactly, 3 3/4 inch for this one here. A little bit larger, 11 centimeters at the thickest point there, 4.25. And I'm not counting the PCI. This one kind of sits out a little weird, it's a little harder to measure. About 12.5 centimeters, 125 millimeters. And then it might actually be exactly 5 inches. Very close. It's hard because it sticks out on an angle. I'd say it's almost exactly 5 inches there. So quite a bit difference there in terms of size. So, I mean, just to summarize the cooling, right? Just before we get into it, before we actually tear them down, wider, the PCBs are the same on all of them. So generally speaking, the same PCB size, right? More or less. Then the differences come down to, and there's actually some differences in where the plate, like the actual layout of them. But other than that, we're looking at longer GPU here, wider this way, and taller with a larger fin stack over here and bigger fans. A little bit shorter here, a little bit less wide that way, a little bit thinner this way with smaller fins as well and a smaller fin stack there, shorter heat pipe. This one here, even more short, even shorter this way, even shorter this way, and a tiny bit smaller fans than this. So these have very similar fan sizes. This has the biggest fan. So that's the difference in the kind of just like the dimensions and size of the cooling itself. Okay, this is going to be a very long video, so you're probably going to want to go through, I'll put chapters in that here, firing on that side. Okay, so in here we do have thermal pad area with some thermal pads there, VRAM on the back of the card. I don't want to destroy that completely. VRAM on the back of the card here. So we do have 1, 2, 3, 4 chips there, 2, 4, 6, 8. The other ones will be on the other side. That type of problem. This one here, I do want to check the sides there, no problem. Okay, that comes off. And I guess we will just release the actual GPU, which should be the last piece, and we should be able to pull off the PCB. Relatively easy to tear down. I'm doing it kind of quick. I'm a little concerned about that plate. It is metal, so you do have metal on there. So the air in your case, so if your case has bad airflow, we'll summarize this. If your case has bad airflow, you're not going to have air blowing over the back of this here, which would, you know, take the heat from these VRAM, these memory chips, into this plate here, and then that cool air would come out and cool this off, evacuate it from the back of your case. If you have a case that does not have good airflow, depending on how it's set up, my case actually does not have front to back airflow. So this actually can be a good test for this GPU because I do not have back airflow in the front of my case that goes to the back. I actually have side intake and top exhaust. It's just a weird case. It's a smaller case. And I think some people will be using these 2-fan GPUs in small form factor cases. So I actually decided I'm going to put it in my NR200P over there, which does not have this. I'll show you in a minute. Does not have the same airflow. So I do worry about those memory chips there not cooling properly. Bam. And hold on. Is that a paste? It almost feels like PTM. That's not paste. They said that they use paste. That's PTM of some kind. I don't know what kind of PTM that is, right? That is a PTM though. See that? So I saw a spreadsheet that lists the difference in the GPUs, and this one was listed to have thermal paste. This is not thermal paste. It's way too dry. It's way too firm. That is some form of phase change material. I don't know if it's, Honeywell PTM 7950 official, 7980, some other brand. I don't know. However, it is not thermal paste. It is not at all. That is 100% some form of phase change material. That's good. I was worried about this GPU not having phase change material and being a problem there. So that's looking okay. So in here, flip that way, we do have more pads, 1, 2, 3, 4. So again, 2, 4, 6, 8. Flip side, 2, 4, 6, 8. So these memory will actually be significantly better cooled than the backside, the ones on the backside of the board here, which does worry me because, I mean, yeah, your memory clocks and that might drop down because they're getting hot, but it's not because these ones are getting hot, it's because these ones are getting hot under here. It kind of reminds me of the 3090 having back-plated RAM. Obviously, this board is being used for both the 8 gigabyte and the 16 gigabyte, obviously. But that's fine. So I'll just add some PTM back to it, but that's looking pretty good. Overall, it's looking nice. We do have heat pipes, 1, 2. So this one comes out here, 1, and it comes back to here. I can see it ending right there. Okay. So we have 2 on this side with 1 looping back, 3 over here. So we have 3 total, 1, 2, 3, short one here, short one here. This one loops back. On this side, we actually have 1, 2, 3, 4 heat pipes. 1, 2, 3, 4, running all the length of the fin stack there. And this fin stack is quite large, right? The PCB ends probably around here, right? So we have a lot of extra, just general fin stack and heat pipes there. So help keeping it cool. So let me just put the PTM back onto this one and we'll move on to the next GPU. One other thing that I do want to point out, the XFX does have a BIOS switch mode there. I don't know which is which, but it does have a BIOS switch mode, basically probably silent and loud. I don't see one on the Sapphire anywhere that I can locate. And the Reaper, same thing. Does the Sapphire have a pulse? Well, I guess we'll find out. Here, same idea. Metal backplate. Right there. Is this a metal backplate too? Yes, it is. Good. So metal backplate there. We'll see if there's VRAM modules on there or not. Freaking long screw. Holy smokes. That was also really tight. Look how long that screw is. And the PCB or the backplate is like directly on that. It doesn't need to be, it could be like 1/10 of that long. All right, well, we take the cooler off from that side. There's the cooler. You can see the actual heat pipes, 1, 2, 3 on the left, 4 on the right. Kind of similar in a way, I'd say. Obviously much shorter in terms of the fins. Are they? The fins are also less dense. I didn't notice that. Look how much more dense the fins are on the XFX. So the XFX will also have denser fins. So just be aware of that. I think it was. Here we go. That comes off. That's significantly lighter. There's just much less metal here. So there's a massive decrease in the amount of metal here on this cooling solution. I would say, I would say probably under half. It's got to be a third. The heat pipes themselves, like there's not a huge difference there, but the actual like radiator amount of surface area metal, and surface area means more surface area for heat to come off into the air when you have fans blowing. So what happens is you have the heat here on the chip, it goes into this copper plate here, it goes into this cold plate here, aluminum cold plate, then it evacuates its way through. You can see there's copper there. Copper goes through there. You might be able to see there's a little bit of copper that touches these heat pipes. These are filled with liquid. The liquid evacuates the heat away because it wants to move hot to cold area, comes through here, that moves into the fins, and the fins blow the air off. So you have more surface area. Part of it is to get more heat pipes. Heat pipes will then evacuate more heat from the CPU die into other areas. But then once they're out here, so there's heat over here, for example, you need more surface area of metal to be blown through. You could put the largest fans in the world, but if you have less surface area, it's going to cool worse because there's less surface area to blow hot air off of. I'm not an engineer, but I have enough science background to understand that. So I do expect this to run significantly hotter. You don't need to do this unless you have very, very high VRAM temps, in which case you could, I suppose, I don't know, put a putty or something on them, or a better thermal pad. I'm not a thermal pad wizard. I do swap them, but I don't think I have enough background to comment on that. But you can research. Oops, you can research it and figure that out. Nope. 1, 2, 3, 4. Same idea. So just like the XFX, the Sapphire has VRAM on the back of the PCB. I wonder if the Reaper will do the same thing. Probably. It's an even smaller card, although the PCB is the same size. If you just have like a limited airflow case, or a case like mine that it just doesn't blow air over the GPU at all, it just doesn't, it's not designed to do that, you will end up with a case where the back plate cooled VRAM might be running hotter than the VRAM over here. Okay, and baby time now. We have the little guy, the little cute guy. Isn't he just cute? I like him. That's screwed back into there. Yeah, so it's similar to the Sapphire. Unlike the XFX, where you could release the backplate straight up, just take off the backplate screws and the backplate just popped off. Here you have kind of screws going like that into the PCB from either direction, and some of them come back up into the backplate. So you actually do need to remove the PCB away from the cooling solution to go on to the next step. Okay. Survey says, bam. So once again, PTM cooling on there, right? The only difference between them is these two here just put PTM on the die, GPU die. These guys just fill the whole copper. It makes no difference, just so you know. It won't make any difference because those are floating, they're not touching anything. Once again, we have VRAM 1, 2, 3, 4, and then we have 4 more on the back here that are going to be cooled that way. So it's going to be the same for all cases. Be sure that you have adequate cooling airflow throughout your case, and if not, just be aware that your VRAM might run a little warm. Same thing. Oh no, it's totally different. In this case, it doesn't have a groove. Makes no difference. Okay, let's summarize. I've torn them all down now. So what's the differences between them other than size? So larger, this is a larger GPU, physically larger GPU, medium size, smaller size, obviously. So that's that there. What do I mean? It's wider, it's taller, and thicker. One step down in all regards, one step down in all regards. What comes from that? It's not just the plastic. We have the largest fan here by far, smaller fan, still reasonably sized, and a tiny bit smaller than that there, but still reasonably sized. So the fans are all kind of good, and all of them there. What we do have here, differences, is they're all using PTM, same PCB size. We're going to have VRAM on the back, half the modules on the back of all the cards, meaning that you really do want to have some case airflow moving through the case to go over the back and get heat off of this plate. That's going to be critical on all three of them where possible. We'll see if that matters, but that is where possible. Now, where they do differ, because they're all kind of, I mean, sure, those are just like numbers. Where they do differ is the amount of, I guess I'd say, surface area on the cooling. So heat pipes are kind of, they all have good heat pipes, whatever. They're all kind of the same there. But these here, you can see that the XFX has around twice the, not quite, but getting, significantly higher density of fins. I'm not sure if it's exactly twice, but maybe not quite, maybe 2/3 or something tighter here. So these are going to be, tighter here, going to be probably around 30% more fins in, in a certain area. So if we look at the same area here, here, and here, you're going to get 30% more fins here, which means 30% more surface area straight up. That's just how it works. They're also taller. So because it's a taller GPU, you have more fin height this way than, for example, this one here. It's a little bit shorter, and this one here is even more short, right? Because it's a shorter GPU. So you get significantly more surface area on the cooling here. So even if the heat pipes are all the same TIM on the die, and same, heat pipes, whatever, all that yada, 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 you're going to get significantly more surface area, even if they were the same size this way, right? You're going to get probably around 30, maybe even 40% more surface area on here, but it's also longer. Right? If we flip this around, it's also a longer GPU. So you're going to get more cooling solution over here, several inches, probably 2 to 3 inches over here, whatever it was, and that way, and you're going to get a little more height this way, and you're going to get more density. Then it steps down, a little bit less dense here, shorter this way, shorter this way. This one here has about the same density, but you're going to be shorter this way and shorter this way. Okay, so here's a look inside the case. It's messy right now. I'll clean up the wires, but just to show you, this is a small form factor case. I'd say like larger small form factor case or medium size. It's the Cooler Master NR200P. No front flow, only top, bottom, and potentially there. So you can see how this is going to be set up. I'm not going to have any airflow flowing through the case. I do have a fan on the bottom. It is 120 millimeter? Yeah, 120 millimeter Noctua low profile, so that will supply air directly into the GPU, so the chip should stay cool. But we're not going to have is any kind of airflow that way. So there's going to be no airflow flying over the back of this here like that way, which would cool it out and get case air out for the VRAM. However, I did add in a side fan here. So that's going to sit a little high. That's technically going to feed directly into the CPU, but there might be a little bit of air that goes down and kind of goes into here. Maybe we're going to have airflow into the GPU from the bottom here, and that's about it. It will evacuate out, and then it's going to basically force its way out that way. Fortunately, the air will generally be moving up away from the GPU in this case, the hot air, because we have air coming in here. It'll come out here, work its way up. This here is going to suck in air, and it actually exhausts out the back. That's the CPU fan with the Noctua. It's going to exhaust out the back there, and I have a 140 millimeter fan out that way. So once the air is coming out of the GPU itself, it should be sucked up and evacuated from the system out this way and out this way. So we don't have an issue with airflow in that regards, but we do have no airflow going over the backplate, or very little. Okay, let's just look at the results here. I was going to do a bar chart, but I realized it's just easier to just present it like this because I can show you the real numbers. So XFX mode 1 and 2, this is quiet mode and kind of like, I guess, not quiet. The Sapphire and the Reaper. So temperature, this is an average of about 10 minutes running after already running for about 10 minutes. I didn't start the test until 10 minutes of running. 54 degrees on the GPU temperature for the XFX quiet, 3 degrees hotter for the XFX non-quiet. So that's super cool. Honestly, that's super cool. It's a pretty big cooling unit for 9060 XT, to be honest. The Sapphire was a little warmer, 60 degrees. I'd still consider that very cool, considering it's a 2-fan in a case that doesn't necessarily have very good airflow. We're looking at 9 degrees hotter than, around 9 degrees hotter than the non-quiet mode, so kind of just going, and just 6 degrees-ish hotter than the quiet mode. So still pretty cool considering it's a significantly smaller card. Then the Reaper is quite a bit hotter. It makes sense. It's a much smaller card. The whole surface area of everything inside is smaller. It's not just that it has smaller fans. There's a significantly less metal in there to be cooled off, and even the back plate in that, there's just less general mass there to be cooled off, even though the fans are still decent sized. So we're looking at 20 degrees, approximately 20 degrees increase over the non-quiet mode to the Reaper there. And the Reaper doesn't have multiple modes, so it was just going and doing what it could. So significantly hotter. But that being said, 72.2 is still not bad for a tiny little GPU in a case that does not have good airflow. And just letting it rip for a long period of time, it's still not bad. Memory junction temperature was something that I was worried about. I was actually worried about the memory junction temperature because of the backplates in that. They're all fine. They're not cool. 84 and 81 on the XFX. The Reaper is only a couple degrees warmer, which is interesting because it has a significantly smaller backplate for air to flow over. And the Sapphire was interestingly much cooler. It could be just the material. Maybe there's just better transmission of heat into the backplate. The tests were all done the same, so it is significantly cooler. That's more where I'd want to see memory junction temperatures. Maybe they use a better pad or something, like a better thermal pad. That's also a possibility. They're all kind of fine, and I think that if you had a better case, like a bigger case with more airflow, like a standard case, where it's a front-to-back style airflow, these temperatures should come down because you would have air flowing over the backplate better. However, that's probably more common with these larger ones. The small one, you're probably not getting a tiny little Reaper to put in a massive case. But you can still get small cases with better airflow. So, it's fine. It's not a problem. It's not throttling or anything, but it is a little warm, and it's because the memory's on the back, I would assume. And if you were to get a better case, better airflow, it would prove that. Hotspot temperature, only 10 degrees hotter on the Reaper here. So a little bit hotter, but it's not as much hotter, I would suppose, between the GPU die or whatever. So again, 90 degrees shouldn't be throttling. Honestly, should be fine. That's voltage. It's just to show the voltage is the same. Now the RPM on the fan is actually quite a bit different. The quiet mode is 1600. The rage mode on the XFX is actually the fastest fan by far, 2000. So that could potentially be partially why it's running cooler. Reaper fans are not only a little bit smaller and the mass itself is smaller, but the fans actually run slower, right? So 15, 16 on that there versus, the slowest on the XFX is 16 and the slowest on the Sapphire is 1700. So part of that could also be, this higher temperatures, just the fans run a little slower. Now, all of them are completely silent. I could not hear the fans over just the case itself. And that case has Noctua fans, which are already quiet. So I just couldn't hear the fans on these here. And I actually took them out and put them onto an eGPU, external eGPU, and just did the test again with my with my laptop because it has Oculink, and I still couldn't hear them. They were completely silent. Clocks are different here. These are probably just base clocks. You could tweak them, right? You can see the XFX runs a little higher, 32. The Sapphire runs a little lower, around 100 megahertz less than that, potentially. And that's going to, that's just kind of factory overclock. You could definitely overclock this more. There's a lot of headroom there. The Reaper is, another like basically 250, 260 under the XFX, and you probably can't overclock as much here because it doesn't have the thermal headroom as much. You still could, I would say, especially if you have better cooling in your case, but in my case, you maybe don't want to add too much because it would start to get a little warm over here, but it's okay. And the memory clocks are exactly the same. So we're basically not getting throttling on the memory clocks. I don't see thermal throttling between any of them. On the XFX here, we're looking at 52 degrees. You can see the differences here. The clocks and everything being the same. The GPU power actually is a little bit higher on the XFX, so we're hitting 181, at least measured there. Over here on the Sapphire, we're hitting 168, at least measured. And on the Reaper, we're hitting 160. So the Reaper actually runs hotter despite using less watts. It makes sense. It's just a mass thing, right? That kind of just makes perfect sense. CPU, it looks like the XFX is actually infecting the CPU a little more because it's dumping a little more heat into the case. That makes sense because it's using more watts. So there's just more watts going into the case to be evacuated out of the case and being pulled in by the CPU. So the CPU is actually running hotter in the XFX. And then, the performance is similar, right? So, I would call them almost margin of error based on what I'm looking at. Like they're not potentially exactly the same scene. It might be like a half cursor off. They're basically the same. Like this is 86, this is 82, this is 84. We're looking at a couple FPS here and there. Frame times are close, right? The low here is a little low, but there might have been, something may have flown through the scene, like one of these things a couple more times or something, or the camera was slightly off, like it was off by, a few pixels to the right, to the left, and that caused that to be a little low. So I'd call the performance basically roughly the same, at least in this scene, in this specific case, despite the fact that it's running a little higher in that too. But yeah, so there you basically go. We're getting around the same performance on all of them. We're getting around the same performance on all of them. The primary difference here is just how much thermal headroom they have, how hot they are, which could potentially mean that, they're going to run cooler if you like that. But it also means that, overclocking down the road, you might have a little bit more room on these two here and even the Sapphire. Whereas the Reaper, you could, but it's starting to get to the point where it's pretty hot already. So let's wrap up the video here. We can say pretty confidently that the 9060 XT 16GB model is essentially the value king of 2025. Hardware Unboxed found the same when they looked at basically prices around the world, not every region, but most regions. It came out kind of just straight up on top. And in Canada here, it is clearly the victor right now. They're just really good value. You get 16 gigabytes of VRAM. You get better ray tracing than last generation. It has excellent performance. It just crushes a 5060. That's my testing. I have a 5060. It just gets destroyed. These are significantly better GPUs. Now, there is a big difference between them. You can go up to 3 fans and get the 3-fan models. I don't think the 3-fan models are necessary. Maybe if you want, they're going to look cool. But, these all run fine. I'll say they run fine. The XFX here runs incredibly cool. Very, very, very cool. You can compare all 3 of them. It's by far the coolest running. And I think this is more than enough cooling, honestly, for this GPU here. So if you prioritize cooling, if you live in a hot place, you have a hot case, not good airflow, whatever it is, this is going to be the winner for sure by, just by being the coolest. Very, very, very cool. Moving over to the Sapphire. It's quite a bit warmer, 60 degrees, which is still, I consider, very cool. Honestly, overall, not really any different there. Some of the hotspots on this was actually cooler, which is interesting. So it does definitely run cooler than even the Sapphire there. It's going to run obviously massively cooler than that there. So if you are worried about cooling, thermal headroom, this is going to be fantastic. The Sapphire here is kind of the sweet spot in my opinion, because it is quite a bit smaller like that. You saw how big that one was. We already have the numbers here, but it's quite a bit smaller here. Like we're looking at 24 centimeters there. It actually is a fairly small card, all things considered. Whatever the backplate's going on here, it just happened to have the coolest memory. None of them had problems, but that's fine. And the hotspot temperature was actually pretty good on this as well. Basically in line with that. But the overall GPU temp was pretty good in terms of size. Like it is a substantially smaller card overall, right? Still around the same, and it's also not as, wide. So depending on your case, some small form factor cases, it's not just about only how long they are, it's also how much clearance you have to the bottom. I was able to get this in there with the ITX case and also have a low profile fan under here with no problems whatsoever. So that length, that height there is going to be totally fine. This one's just a little bit thinner, just slightly over 2 slots. So if your case is really restrictive, you'll have easier time getting this in, and it runs cool and quiet. So I think it's, this is probably the sweet spot for me. It's kind of right in between. It's not quite as bulky and large as that, and a little smaller, but the thermals are basically the same. Now the Reaper actually does run fairly warm, but I don't see it as a problem because once again, it's not thermal throttling or anything like that. And so despite the fact that it is this is a tiny little GPU, right? Like it's the size of my hand, right? Like it's a tiny little thing. And despite that, it doesn't run too hot, right? It was running at 72 degrees on average, which, yeah, it's not like cold, but it is certainly not a problem to run a GPU at 72 degrees. There's no problems running a GPU at 72 degrees, especially this one. It's not even close to throttling, no problems there whatsoever. And I ran these tests for a while. Like I ran for like 15 minutes before I even hit the record button So, I mean, this data is actually after running it for quite some time, and there's no problems with the temperatures here. I mean, it is a lot warmer than these, 51-ish, 51 and 54, depending on the mode. Over here, 60 degrees. Again, that's pretty cool. 72. So it is a lot warmer than these, like 20 degrees difference delta between the two of these. But again, it's not hot. It's just hotter, because this is overkill cooling. This is probably about average for a 9060 XT, I would say. And this one is like a smaller size of it. If these, if these were 200, 250 watt GPUs, this would probably run too hot. But there's no problems. Honestly, it runs just fine. So there's less overall like thermal headroom here, but it's just such a cute little thing. It's just a cute little card. Like just having a GPU that is like that tiny is just super cool to me. So they're all sweet. Pick the one you want. I don't think in any case you're going to need a 3 fan. If you're thinking about, well, okay, maybe I can't get a 2 fan, it's going to be too hot. No problems. Honestly, they're all fine. Go with what your gut tells you. They're all going to be good. I think for the average person, whatever, just probably this one, just based on just like, it's fine. It's the middle one, but I think all of them are fine. Honestly, no problems whatsoever.